Motor Control Centers, or MCCs, provide a method for grouping motor control as well as associated distribution equipment. In this video, we'll explore the fundamental construction and essential role MCCs play in managing and protecting electric motors in various industrial and commercial applications. An MCC is a freestanding electrical assembly comprised of one or more vertical sections that share a common horizontal power bus. Each vertical enclosed section typically contains several motor control starter units or buckets, with each getting power from a vertical bus that connects to the horizontal bus. Each bucket in an MCC holds electrical parts that control the power going to a motor or other equipment. These parts are chosen based on the load, like voltage, current, frequency, and horsepower. The main job of these components is to safely start and stop the motor and protect it from problems like short circuits, overloads, and phase failures, which can cause serious damage. A motor starter unit can include different types of motor controls, circuit protection, power meters, surge protectors, energy management tools, and more. Eaton MCCs may be applied on electrical systems up to 600 volts at 50 or 60 hertz, having available fault currents of up to 100,000 amps RMS. DC motor control centers are available up to 250 volts DC, having available fault currents up to 22,000 amps RMS. An ongoing temperature and short circuit design test program, as required by UL 845, ensures a quality product that meets the latest safety codes. Let's go over the details regarding the actual MCC structure and construction. The typical height of an MCC structure is 90 inches, with 9-inch horizontal wireways at the top and bottom for wiring. The remaining 72 inches are used for mounting control units, which can be arranged in various configurations and sizes. For front to back structures, the top horizontal wireway is 15 inches high and the bottom is 9 inches, providing 66 inches of usable space in the rear. MCC enclosures come in various types, including NEMA Type 1, 2, 12, and 3R. Type 3R enclosures can be non-walk-in or walk-in aisle. Each structure includes a vertical wireway on the right side that extends along the full height to accommodate wiring. The top front horizontal wireway spans the full width of each structure and is isolated from the main horizontal bus. The bottom horizontal wireway extends the full depth of the structure, allowing for unrestricted conduit entry. The bus system efficiently distributes power throughout the MCC and provides mechanical strength during faults. The vertical bus distributes three-phase power from the main horizontal bus into the vertical compartments. It has a unique Z shape for added strength and smooth connection, as well as the ability to mount buckets in the front and back side of the MCC. The vertical bus is available in ratings of 600, 800, and 1200 amps and is made of tin-plated copper for durability. The vertical bus compartment is isolated from the unit compartment by a full height barrier. Optional labyrinth design barriers provide protection against phase-to-phase insulation breakdown, and an automatic shutter mechanism prevents exposure to the vertical bus during maintenance. The main horizontal bus distributes three-phase power from the incoming line to each vertical structure. It is mounted edge to edge for strength and is available in ratings from 600 to 3200 amps. The bus is isolated from the top horizontal wireway by a metal barrier, allowing easy access for maintenance. For three-phase, four-wire applications, a neutral landing pad is provided. Optional half or fully rated neutral bus can be supplied. A copper ground bus rated at 300 amps is mounted across the top of each vertical structure as standard, or can be mounted across the bottom when the bottom 9 inches are not occupied by units or master terminal blocks. Now that we have covered the overall enclosure, bus system, and wireways, let's discuss the actual buckets themselves that may be bolted in or removable, and the components that get installed inside the buckets. There is also a unique option for Eaton's FlashGuard bucket that adds an additional level of personnel safety. Specifically designed bus stabs, insertion guides, handle mechanisms, wrapper, terminal blocks, and safety interlocks are added to form a standardized plug-in unit that meets the highest safety standards. Tin-plated copper alloy self-aligning stabs are mounted in a glass reinforced plastic insulation block that totally shrouds each stab and ensures positive alignment of the stabs with the vertical bus. The insulation block is also an integral part of the phase-to-phase isolation system. The power wiring is welded to the stabs and is totally contained within the unit enclosure, which means the vertical bus compartment is completely free of wiring for safety and reliability. For additional safety, Eaton's flash guard buckets are equipped with a retractable stab mechanism called RotoTrack that withdraws the stab assembly off the energized bus bars and into the bucket. A spring-loaded shutter then automatically closes off access to the bus bars, which allows the electrical worker to connect and disconnect power to the bucket with the unit door closed, thereby minimizing exposure to arc flash. A visual indication is provided on the unit door showing the connect and disconnect positions of the RotoTrack, as well as the position of the shutters that enclose the stabs. The bucket can be racked manually or remotely using a wired pendant that is attached to a RotoTrack remote operator, allowing the operator to be outside the arc flash boundary. The unit wrapper is equipped with a quarter-turn side wrapper latch that securely holds the unit to the compartment. The latch can only be engaged when the stabs are fully mated with the vertical bus. Upon release of the latch, the unit can be partially withdrawn such that the stabs disengage from the vertical bus. In this position, the latch can be re-engaged to prevent the unit from being returned to the fully stabbed position or from being removed from the structure. The latch can be padlocked in this position to ensure that the stabs remain disengaged during maintenance. The handle mechanism is designed to provide a high mechanical leverage so that little effort is required to operate any device. The device has 4 positions: on, off, tripped, and reset. Only circuit breaker types have tripped and reset positions. It is securely mounted to the front of the unit and mechanically connected to the breaker or fusible switch, eliminating alignment problems. The device panel can accommodate up to 6 30mm pilot devices such as oil-type push buttons, indicating lights, selector switches, and miniature meters. Voltage detectors and absence of voltage testers are also available to be installed on the device panel and allows the end user to improve lockout-tagout procedures. Molded into the panel are knockouts to help with future additions of devices. Terminal blocks are mounted in knockouts on the vertical wireway side of the bucket, affording greater access to the unit compartment and its interior components. The 2-piece terminal block snap locks together to ensure permanent circuit continuity. The incoming line section is where the line cables enter the MCC from either the top or bottom and are easily terminated onto main lugs or connected to a main disconnect. All incoming line sections comply with NEC wiring bending requirements as adopted by UL. The common equipment installed inside a bucket include motor starters, soft starters, variable frequency drives or VFDs, a surge protection device or SPD, a power meter, and feeder disconnects. A typical bucket used for motor protection and control consists of a starter and a disconnect device of proven capability. The disconnect device can be a high interrupting motor circuit protector or HMCP, thermomagnetic breaker, or fusible switch. In a motor control center application, the starter's overload relay protects the load or motor against overload currents. The HMCP or fuse are used to permit the high inrush current of the motor while starting and protect the motor from high fault currents during operation. A soft start can be used to limit inrush currents to larger motors. A VFD can also limit inrush current and control the speed of the motor. Feeder units are available with either molded case circuit breakers, power circuit breakers, or fusible switches that feed a variety of different loads with different power levels. Molded case circuit breaker units are available as draw-out up to 400 amps, with dual mounting available up to 150 amps. Units above 400 amps and up to 2500 amps are fixed mounted. Power circuit breaker units are available as either fixed mounted up to 2000 amps or a draw-out up to 3200 amps. Fusible feeder units use a visible blade disconnect switch and are mounted in draw-out units through 400 amps with 30 and 60 amp ratings available in dual mountings. Fixed mounted switch ratings of 600 and 800 amps are also available. There are other special applications that can be installed in an MCC, which include an automatic transfer switch or ATS, transformers, panel boards, and more. An ATS can be installed to control main tie or main tie main operations of power circuit breakers or contactors. 3-phase dry type distribution transformers can be installed in an MCC up to 45 kVA. They can be used to feed specific loads or a panel board that is also mounted within the same MCC. There is generally a high risk of arc flash associated with MCCs since they are commonly hard to de-energize and often worked on while hot. Some special applications that add an extra level of safety to an MCC are arc-resistant construction and the ability for remote racking and operation with Eaton's flash guard buckets. Eaton's Freedom arc-resistant MCCs are specifically designed to contain arc blast energy, enhancing workplace safety with an additional layer of protection. These MCCs are engineered with reinforced steel, latches, and hinges to provide containment of internal faults inside a space-effective package that has a Type 2 accessibility rating, ensuring arc resistance around the entire perimeter of the MCC. The width of an arc-resistant MCC is 8 inches wider than a standard MCC, with 4 inches added to the left and to the right of the lineup to allow for gas to expand if an arc occurs. The depth of the MCC is 21 inches and is front mount only. The Freedom arc-resistant MCC does not need any venting or plenums to vent the gas, allowing it to be mounted up against a wall or a ceiling to be brought down to the top of the MCC. Eaton's Freedom FlashGuard motor control centers are an industry first in addressing the dangers associated with an arc flash event by minimizing the risk of arc flash exposure. This is done by using the Rotatrack retractable stab mechanism that was discussed earlier in this video. In addition, a number of safety interlocks prevent scenarios where removal or insertion of the FlashGuard bucket could compromise arc flash safety. Eaton's FlashGuard arc-resistant motor control centers combine the arc containment features of Freedom arc-resistant motor control centers and the arc mitigation features of Freedom FlashGuard motor control centers to provide the safest available option in the industry. Here at the Power Systems Experience Center, we have several different MCCs that can showcase many of the features and products we covered during this video. To learn more about motor control centers and their many options, contact us or your local Eaton representative to schedule a visit to one of Eaton's Power Systems Experience Centers today.